sort of gears one. Transmission of rotational effect. I'll start with a simple problem. Yeah. These are the machine which will rotate this particular pulley. It is rotating with angular velocity 5 radians per second. Then what will be the velocity of some point P on this particular pulley? (4 meter), this is 3 meter, this is 5 meter, this is 4.5 meter. Diagram, it has become a little bit blurred. I'm adjusting all that one. What is the question? I just want the speed of the point P. See, one thing, this is about the only pure rotational effect. So questions can be asked similar to of this kind. So let's do one thing one by one. What is the velocity of this point? What is the velocity of? So I'll start with P1. Then velocity of point C. Then I'll calculate velocity of point B. Velocity of point, or if you want to write velocity of point, anything. I'll start with point A. Or if you want, you can go for velocity of point A. What is velocity of point A? Should be equal to 4.5 into omega A. And how it will be? It will be directed downward. And the velocity of point P should be upward. So Vp1 should be equal to Va. Then this is a string. This is a string. Then string is inextensible. So therefore, what should be the velocity of point? So this is a string. So where it is wound, it is wound on this particular thing, like this. You can see. So what is the velocity of point C? Velocity of point C should be equal to velocity of point P1. Vc must be equal to Vp1. Then this pulley this particular pulley will be connected to this by this particular set of strings or belt, whatever it can be, that one. So then velocity of this point should be equal to velocity of this point. So how do it will rotate now? This angular velocity. So velocity of point C is upward, no? Then how the angular velocity of this? This is omega A. Omega D, I'll call it. Then we know Vc. Can we calculate angular velocity? So Vc is equal to 5 meter into omega D. Able to get this? Just circular motion concept. And now we know angular velocity. Can we calculate velocity of this point? P2. Velocity of point P2 should be equal to 3 into omega D. And velocity of point P2 should be equal to velocity of, also like a speed of point B here. And why we should equate? String is inextensible. So velocity, this tangential velocity which is directed now, should be equal to this one. Not visible. Okay, but this is velocity of point P2. So what is velocity of point P2? Should be equal to 3 into omega D, radius vector into angular velocity. And velocity of B should be equal to velocity of P2. And velocity of B should be equal to, sorry, the speed of B should be equal to speed of point P, because just trying to relate any 2 points on the belt must have the same velocity because string is inextensible. So this about, it's a part of our syllabus, not there in our books, but can be asked in advance. You have to be careful. I'll come to this one. Now this is about the gates. We do try to open, like if you check the toys, no, especially cars nowadays which are coming, no, you can see these are the gears here. How do I can rotate this particular gear? So he's asking now omega h. These are called like a gears. This called like a shaft. If you see the technical, this called like a shaft. This called like a wheel. The wheel, what will happen? The wheel, it is it's going to have the teeth. I'm going to make it. Now, all of you, teeth, shall I call that? These are called like a teeth. Not just smooth that one. I'll make that one. Then as I rotate the wheel A, this called like a gear, huh? The operation of reverse for a 3-speed automotive. Okay, don't bother anything. Just come for this one. The gears. What do you mean by gear? This is called like a gear. It will have a radius R. This will call it as a gear. I'll rotate the first gear A with an angular velocity of 60 radians per second. Then what is the angular velocity of the gear H is what is asking, omega H. And they are related by, they're just linked by this particular setup. So how to calculate the angular velocity of the gear H? So I'll write the relative, the radii of that one. There's a part of syllabus which are not there in SU or mass, engage, anything can be asked. You have to be very alert. So again, don't just leave that, sir, like most of the books not discussed, so we'll leave that one. So I'll give all the radii. This will be 90 millimeter. Carry on. RB equal to 30 millimeter. RD is equal to 50 millimeter. R equal to 70 millimeter. And RF or RH, this should be 60 millimeter. Look at now. So the diagram, it is in contact with the gear B here. So if you are getting confusion, one by one, only I'll draw a circle. So it'll be very difficult for me to draw that teeth, everything. So there's a gear A which is rotating with an angular velocity, let's say omega A. Then I'll show. One diagram, I'll show it. The teeth of one gear should exactly fit into other one. Then only the gears can rotate here. Otherwise, not possible. This is gear A. This is gear B. Then all of you, this diagram is very important. Now I think everything visible clearly, very clearly for you. Just do notice here. Angular velocity omega A. This will be how the velocity of this point here. Point P1 let me call, and this is velocity of point P2. And most of the books, what happen, we do have like this, two cylinders, they come. I think this is a, nowhere in the world the gates will be like this. The gates must be there. You do one thing today, you can purchase toy around 150 rupees or 70 rupees, between 70 to 150 if you purchase, no, you can see the plastic one, and one will be, one or two will be metal, some 4 5 6 will be there inside that. Do notice as you move the car, what happens, the different gears will be rotating and they will make the wheel to rotate finally. Do open it, because I can't explain everything in the diagram. Practically see once, it'll be okay. Now there's a velocity of point P1. There's a velocity of how the this gauge should rotate. This is rotating anti-clockwise. What about this gauge? The velocity of point P1, P2 must be equal, no? Then only they can be in contact. After some time, this point will come in contact with this particular point. Is that okay? The mechanism, are you able to understand? Or you just do one thing, take in your kitchen, you do one thing, big plate you take, small plate you take, try to rotate that and do markings. If you are not getting the gear, no, do markings here and see that how do they rotate. And now what should be the velocity of V1? V1 should be equal to RA omega. RA omega. What should be the velocity V2? RB omega B. V1 must be equal to V2. So therefore, RA omega A should be equal to RB omega B. So what is the angular velocity of this? RA omega by RB. How the angular velocity of omega B should be? Look at the velocity of V2, tangential velocity V2. So therefore, the angular velocity of this gate B should be clockwise. Now we know that gate B is rotating clockwise. Now come for gate C and gate D. So finding very difficult, just put individual diagrams. And now gate C and gate D. So how the gate C should rotate according to this clockwise. So this should be the diagram. Gate B and D, gate C and B are they're connected just by a rod like this. How is it in this one? Opposite to that one, huh? It should be. Gate A was having angular velocity like this. So it should be opposite to that. So it should be like this here. Then omega C should be in this direction. Now omega C and D you bring in contact. This is C and this will be D. C, let's assume that I think I'll change the diagram from here because we'll stand here and just a small correction I'll make it so that will be easy for you. Yeah, this will be easy for you now. VP1, VP2. So when this rotates like this, the angular velocity of this should be in this direction. So we are standing at this particular point and making. So is it okay? No, omega B justified. This person is what going to make observation here. You will see that it is like this omega A. Then omega B should be in this sense. I'll indicate everything here. This is omega C. So let's come for this omega C like this. Then the velocity of this point should be equal to velocity of this. Then how the angular velocity of the gauge C should be? It should have velocity like this Vd. This is Vc. Omega D. Then again equating Vc equal to Vd. Rc omega C equal to Rd omega D. We know omega C should be equal to omega B. Any reason? Because they're just connected by a rod. You look at in the toy, the two wheels should have same angular velocity. The two wheels or the two wheels of a vehicle, car, not two-wheeler, four-wheeler. They must have same angular velocity, the front or the rear wheel. The pair of that wheels must have same angular velocity. Okay, I got the omega D. Now omega D again, omega D and the wheel D and D again, they're connected by a one shaft. This is called like a shaft. That rod is called as a shaft. Nobody will call it as a rod in the technical terms. I'm not showing the teeth. for the gear. So this is the gear D, this is a gear E. Now, how is omega D account to this? Should be like this, no? Then how omega E should be like that? Any reason for that? Any reason for that? Because they're just connected by a shaft. So with what angular velocity the gear D will rotate, with the same angular velocity the gear E will also rotate. So the according to the diagram, the omega D should be like this, and the omega E will be like this. Let's come for the gear H. Gear F is telling. So I'll come for the next one. So here the gear. So what is the angular velocity of this is, I think this is the lower one is here. So this is like this, omega E. Then omega F should be like this here. These velocities should be equal. So this is gear E, this is gear F. With what angular velocity the omega F will rotate, that would be the angular velocity of H, that one. Now what is the equation? Again, you can write it here. Omega D is equal to omega E. But here you should not write. Here what you should write? RF omega F should be equal to RE omega E. And omega F is equal to omega H. Angular speed of the drive, shaft H. So that rod, there's a rod, no? There's a shaft. What is the angular velocity of that shaft? And that particular shaft is connected to gear H. So that's what we are showing it here. So I think F is okay, that one, omega F, and this is final our answer. You have to just do calculation. I think it's nothing is there. So what you should do, like you should make that as a plane diagram. That's the only thing. Either you be on the right hand side of this diagram or left hand side. Then construct a plane diagram. These are called like a teeth. They should be in contact. Please do make observation practically. They should be so designed that the teeth, what happens, should be in contact. Now you have to ask question. What makes the gear be to rotate like this? I think the teeth, what happen, they'll push this teeth, what happen, will push this teeth, no? That will make it to rotate. And to avoid all that happen, I'll go for greasing. Grease, all of you, grease. It's like a viscous liquid, no, which we applied. So to avoid the damage of gears, what happen, we'll go for greasing that one. This is the purpose here. Diagrams can be like this, so you have to be very careful. I'll scroll down. The tangential velocity, the linear velocity of this teeth must be equal to linear velocity of this teeth. I think this is something wrong. I should show that teeth, because if they are just like this, cannot rotate. I'm telling this one. Practically no gear is available like this. This will be the real diagram. This for our understanding purpose, I drew it. So if you please don't draw circles. This will be against our